This video is to remind you how to simplify radicals in case you've forgotten. So make sure that you watch this video if you need a refresher on how to simplify a radical. Before we simplify any radicals, we need to make sure that we know the first 15 perfect squares. Obviously, the more perfect squares you know past 15, the easier this is going to be, but at least know the first 15 perfect squares, okay? So I'm going to simplify the square root of 54. It is not a perfect square. So what I'm going to do is I'm going to make a list of all my perfect squares from 1 to 200 or 1 to 15 squared. So 1 squared is 1, 2 squared is 4, 9, 16, 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. Now, when I make my factor chart for 54, I'm only concerned about these numbers. I don't care about any other numbers. So let's go ahead and make the factor chart. So if I were to write 54 down, the factors of 54 that are perfect squares are going to come from this list right here. So 1 is a perfect square, so I'm going to put it in my list. It's not really that helpful though. The next perfect square is 4. Now 54 is divisible by 2, but I'm not going to put it in my chart because 2 is not a perfect square. So the next perfect square is 4. 54 is not divisible by 4, so I'm not going to include that in my chart. The next perfect square after that is 9, so 54 is divisible by 9. I will include that in my chart. So I have 9 and then I have 6. Now what I'm going to do is I'm going to look at this 6 that's left over. And I'm going to see if 6 is divisible by any other perfect squares. 6 is only divisible by 1, 2, 3, and 6. 1 is the only perfect square, but it really doesn't make any difference if it's 1 or not. So this right here, this 9, is the largest perfect square I can divide 54 by because this has no other perfect squares in it. So I'm going to use 9 and 6. So I'm just going to split this up into the square root of 9 multiplied by the square root of 6. Now remember, I haven't done any square rooting yet, so these are both under radical signs, okay? Now I can square root 9 evenly, and the square root of 9 is 3. Since I have square rooted it, I don't need the radical anymore. That's a common mistake. A lot of people will think that they still need to put a radical here. You don't. And then 6 is not square rootable, so I've got 3 radical 6. And this is as simplified as it possibly can get. Okay? One quick note that I need to make before we move on to the next example is that you are required to show this workout. You cannot go straight from this to this at this point in time. Okay? The next example is 80. So I'm going to make a chart for 80. So I'm going to see what numbers that are perfect squares that are also factors of 80. So 1 is my first perfect square. Obviously that's going to work, so I'm going to use 1 in 80. The next perfect square is 2 squared, which is 4, so I'm going to put 4 here. And 4 is a factor of 80 combined with 20. Now I'm going to look at this 20 and see, is there anything that 20 is divisible by that's a perfect square? It's divisible by 4, so that means that this is not the largest perfect square possible. So next is 3 squared, which is 9. 80 is not divisible by 9, so I won't include that in my chart. The next perfect square is 16 because it's 4 squared. 80 is divisible by 16, and then the other factor would be 5, which is prime, which means it's not divisible by any other perfect squares except for 1. So this is going to be my largest perfect square that I'm going to use. So this turns into square root of 16 times the square root of 5, and then remember I haven't done any square rooting yet, so I still need to have my square roots here. My symbols still belong, but once I square root that 16 I end up getting 4, so this turns into 4 times radical 5 because I cannot square root that 5 any further or simplify it any further. Now that's one way to look at it. Another way to look at it is, let's say you didn't go through your entire chart and you accidentally chose to use 4 and 20 instead of 16 and 5. Look at what's going to happen if I were to do that instead. So I'm going to take the square root of 80 and I'm going to split that up into the square root of 4 multiplied by the square root of 20. So then this ends up becoming 2 times the square root of 20. Now, the danger of doing this without the largest perfect square is that you may stop here and think that you've completely simplified it, but you haven't, because that 20 is divisible by another perfect square, which is 4. So I'm going to take the 20 and split the 20 up into the square root of 4 times the square root of 5. And I have to copy this 2 down right here because it doesn't just disappear. So I'm going to copy my 2 down right here. And then this turns into 2 multiplied by the square root of 4, which is 2, times the square root of 5. So you end up getting 4 radical 5 either way. I highly suggest that you put in the effort at the beginning, find the largest perfect square. It makes it so much easier when you're trying to simplify. Now, one last example I want to go over with you is the square root of 225. Now, a lot of people will see something like this and they're already so used to simplifying radicals that they'll try to split this up into 2 different perfect squares that you can divide 225 by. But if the number is already a perfect square, don't go through all of that trouble. The square root of 225 is just 15, and then you are done with that problem. And hopefully this will help clear up any confusion that you have about simplifying radicals.